In this video, we're going to talk about how to calculate the density of a mixture of gases. So first, we need to calculate the average molar mass of a mixture of gases consisting of methane and nitrogen, and we're given the volume percent, which you can also say is the mole fraction. So 30% of all the molecules is methane and 70% is nitrogen. Keep in mind, moles and volume are proportional when dealing with gases. So the mole fraction of methane is 0.3 and the mole fraction of N2 is 0.7. So how can we calculate the average molar mass of this mixture? So basically what we need to do is take a weighted average. So we're going to multiply the first molar mass times its percentage, which I'm going to call P1, plus the second molar mass times its percentage in the form of a decimal. So the molar mass of methane, that's C plus 4H, so that's 12.01 plus 4 times 1.008. That's equal to 16.042. Now we need to multiply it by its percentage, which is 30% or 0.30. Now the molar mass of N2 is 14.01 times 2, so that's 28.02, times its percentage, which is 0.7. So the average molar mass should be somewhere between the molar mass of methane and nitrogen gas. Now here's a question for you. Do you think the average molar mass is going to be closer to the molar mass of methane, which is about 16, or the molar mass of N2, which is about 28? Now notice that the quantity of N2 is much greater than the quantity of methane. So therefore the average molar mass should be closer to 28 rather than 16. So let's go ahead and type this in. 16.042 times 0.3 plus 28.02 times 0.7. So this will give you a weighted average of 24.43, which is closer to 28. So that's the average molar mass of this mixture. Now once you have the average molar mass, you can calculate the density of that mixture. Perhaps you've seen in another video that I had on gas density and molar mass, I came up with this equation. D is equal to PM over RT. You can derive it using the ideal gas law equation, but that's how you can calculate the density if you know the molar mass. Now the pressure has to be in ATM. So to convert it to ATM, take 800 and divide it by 760. So that's going to be 1.0526 ATM multiplied by the molar mass of 24.43 divided by R multiplied by the temperature, which is 300 Kelvin. So now let's multiply 1.0526 by 24.43, and then let's divide it by 0.08206 and by 300. So you should get a gas density of 1.045 grams per liter. So that's how you can calculate the density of a mixture. Find the average molar mass and then use this formula to calculate the density. Let's try this one. The density of a mixture of gases consisting of neon and argon is 0.9019 grams per liter at 400 Kelvin at a pressure of 900 torr. What is the average molar mass of the gaseous mixture? So recall that we said that the density is equal to the pressure times the molar mass divided by RT. So we need to solve for M in this equation. Let's multiply both sides by RT. So D times RT, that's simply going to be DRT. And that's going to be on the left. And on the right side, these two will cancel, leaving behind PM. So all we got to do is divide both sides by P. So the average molar mass is going to be equal to the average density times R times T divided by the total pressure. Now let's go ahead and use that formula to calculate the average molar mass. So we have the density, which is 0.9019 grams per liter. And then we have the R value, which is 0.08206 liters times ATM divided by moles times Kelvin. And then we have the temperature, which is 400 Kelvin. All divided by the pressure, which is 900 torr. But we need to change that to ATM. So let's divide it by 760. And so the pressure is 1.1842 ATM. Now we can see that the unit liters will cancel, Kelvin will cancel, and the unit ATM will cancel, leaving us with grams per mole. So it's 0.9019 times 0.08206 times 400 divided by 1.1842. And so I got 24.999, which I'm going to say it's about 25 grams per mole. So that's the average molar mass of the gaseous mixture. How can we use it to calculate the mole fraction of each gas? First, let's get rid of some stuff. Now recall that we said that the average molar mass is equal to the molar mass times the percentage for each substance. If there's only two gases, this is it. If there's a third gas, you can add another term and so forth. But we only have two gases. Now we have the average molar mass is 25. M1, we could use the molar mass for neon times the percentage of neon, which we need to find. And M2 is going to be the molar mass of argon times the percentage of argon. So let's say that the percentage of neon is X. The molar mass of neon is about 20 if you round it to the nearest whole number. And the percentage, we're going to say it's X as a decimal. The molar mass of argon is about 40, and the percentage has to be 1 minus X. Let's say if this is 30%, then this has to be 70%. It has to add up to 100. 30% is 0.3, 70% is 0.7. So if X is 0.3, then 1 minus X, or 1 minus 0.3, is going to be 0.7. And that's why we could set it up this way. X plus 1 minus X will always add up to 1, and 100% is equivalent to 1. So now let's calculate the value of X. So on the right side, we need to distribute 40 to 1 minus X. So this is going to be 40 times 1, which is 40, and then 40 times negative X, which is negative 40X. Now, let's combine like terms. 20X minus 40X is negative 20X. So it's 25 is equal to 40 minus 20X. Now I'm going to take this term, move it to this side. So I have 20X plus 25 is equal to 40. And now I'm going to subtract both sides by 25. So 40 minus 25 is 15. And now to get X, I got to divide both sides by 20. 15 divided by 20 is 3 over 4, which is 0.75 as a decimal. Now, the percentage of neon is equal to X. So it's 75% neon, which means it's 25% argon. If you do 1 minus 0.75, this will give you 0.25. So we could say that the mole fraction of neon is 0.75, and the mole fraction of argon is 0.25. Now it makes sense though, because the molar mass of neon is about 20, and the molar mass of argon is about 40. but the average is 25. So the average is closer to neon. So therefore, we should have a higher mole fraction of neon, which in fact we do. So now that we have the mole fraction of argon and neon, what are the partial pressures of each gas? So what is the partial pressure of neon? The partial pressure of neon is the mole fraction of neon multiplied by the total pressure. So it's 0.75 multiplied by 900 torr. So it's going to be 675 torr. So that's the partial pressure of neon. The partial pressure of argon is the mole fraction of argon multiplied by the total pressure. So that's 0.25 times 900. And so that's going to be 225 torr. So now you know how to calculate the mole fraction and the partial pressure of every gas in a mixture if you're given the density of that mixture along with the temperature and the pressure. Now keep in mind, if you're given the density at STP, just remember that the pressure is 1 atm and the temperature is 273 Kelvin.